Okay, hi. Okay, this is actually a brief explanation on animalia. So the first part of animalia is very important for you to understand the other parts or the other subtopic in this chapter. Okay, we go into animalia. Okay, for the introduction. Okay, so these animalia, they are multicellular eukaryotes. Okay, perbezaan dia dengan multisel yang lain, organisma multisel yang lain ialah dia mempunyai specialized cells, okay, which are the nervous cell and also the nerve cell and also the muscle cell. So these two, muscle cell and nerve cell, they will organize into muscle tissue and nervous tissue. Okay, and both of them are responsible for the movement and for the impulse conduction. Okay, so these two function that have been found in multicellular eukaryotes ni, animalia ni tak ada pada multicellular organisma yang lain. Dia ada muscle cell dan juga nerve cell. Okay, and then the second is they are heterotroph, means they cannot produce their own food. Okay, dia perlu ingest, dia perlu ambil makanan either living organism or non-living organism, and then there are enzymes that will digest the food after the food has been ingested. Dia bukan macam fungi. Fungi dia boleh keluarkan dulu enzim, enzim tu akan kita panggil exoenzyme. Enzim tu akan digest dulu the material and then later the fungi will absorb the nutrition. No, but for animalia dia akan ingest dulu baru the enzyme digesting enzyme will digest the material to be absorbed. Dia tak macam fungi. Okay, most are capable of locomotion at some time during their life cycle. Kebanyakannya diorang boleh bergerak lah. Most have nervous system and muscle system. Most are diploid and they reproduce bisexual. Okay, sexual reproduction, and they inhabit marine environment, fresh water and land. So this is the phylogeny ataupun asal usul animalia. Okay, so biologists they have agreed that these animals, these kingdom animals are come from protists, especially from the colonial flagellates. Okay, so awak check balik pada awak punya lecture notes chapter 4. Colonial flagellates ni yang mana? Dia mesti duduk dalam koloni dan dia mempunyai flagella. So check balik dia group yang mana. So biology ni semua setuju bahawa animalia come from protists yang flagellates. Okay, so the cell becomes specialized to perform specific function for the movement, for the feeding and reproduction. Okay, sekarang ni bila dah masuk animalia, cell dia dah start specialize. Okay, untuk certain activity. So bila dia dah ada specialization, okay, dia akan between each cell there are cooperation and coordination. Okay, to form a single organism. Kalau sebelum ni hanya pada sel saja, fungsi asas sel. Sekarang dia dah membentuk tisu, dia dah membentuk sistem, and later on dia akan membentuk organism. Dia dah becomes towards more a complex system. Dia tak macam dia tak ringkas lagi. Okay, sebab dia dah dalam dia punya construction phylogeny ataupun dia punya taxonomy tu dia dah become more complex. Okay. So this is the origin of animal from flagellated protists. Okay, so kita tengok dekat sini, dia from this single cell satu ni ada flagella. Okay, so each of the protists ni dia akan membentuk satu koloni. Later on this colonial protists, okay, they will become a one cell. Okay, one cell, and semua satu sel yang sama. Okay, semua sel yang sama. Later on dia akan evolve menjadi specific cell. Okay, for example this three cell it becomes reproductive cell. Later on this cell bila dia dah ada function dia tersendiri, so dia akan start the process. Dia akan coordinate membentuk dia punya fungsi. So dia membentuk gastrula like proto animal. Kalau awak recall balik untuk pertumbuhan ataupun kejadian human, kita akan bentuk gastrula ada bentuk bulat, and then dalam ada satu ruang sebelum pembahagian human tu complete. Ni ialah dia menunjukkan ialah carta alir lah bagaimana berlakunya development of animal from a single cell of protists, and they become colony, and then later on they coordinate and specialize into an organism. Okay. Biologists divide animals into parazoa and eumetazoa. Okay, what is parazoa? What is eumetazoa? So these parazoa, they possess multi-cell that extremely versatile. Okay, and can change their shape and function. Dia lebih versatile, dia tak spesifik. Dia boleh berubah bentuk dia dan juga fungsi boleh berubah. Okay, and they are not organized by tissue. For example, sponge. Kalau kita tengok bentuk sponge ni, awak tengok balik pada lecture notes, bentuk dia semua sama. Okay, semua sama. Dia tak ada spesifik shape and tak ada specific function, dan shape dan function dia boleh berubah-ubah. Okay, all animal species other than sponge have true tissue and classify as eumetazoa. Kalau organisma yang ada specific function, ada specific shape, kita panggil dia sebagai eumetazoa. And mostly, okay, most of the animals are eumetazoa. So the classification of animals can be done according to 4 criteria. The body symmetry, macam mana pembahagian badan dia. Sama ada dia bulat, kita panggil radial. Maksudnya dia setiap sudut dia semua sama. Ataupun bilateral. Bilateral maksudnya dia dua sahaja. Badan dia ada dua keratan saja. Atas dan bawah sama bentuk. Bila kita keratkan dia, dia sama bentuk. Okay? So bilateral and radial. The body cavity, macam mana ruangan dalam badan dia. The pattern of development and the molecular data. So the body symmetry involve 2. Okay? The first one is radial symmetry. Okay, multiple planes can be drawn through the central axis. Maksudnya, this is central axis. So, ada banyak plane. Okay, satah ada banyak. So, bila dikerat, semuanya menjadi bentuk yang sama. Itu maksudnya radial symmetry. Animals with radial symmetry receive stimuli equally from all directions. So, dia boleh menerima stimulus, okay, ataupun rangsangan dari semua kawasan. Semua sama. And then we go into bilateral. Okay, the body plan can be divided through only one plan. Maksudnya dia ada satu saja. Okay, atas dan bawah. Okay, which passes through the middle of the body. It produces equivalent right and left half that are mirror image. Okay, so kebanyakannya adalah bilateral. Okay, kalau awak tengok insect kan, contohnya belalang. Okay, dia ada bahagian left and right. Okay, kebanyakan insect dia ada ni. Contoh kalau yang bulat macam sea urchin, bentuk dia ada bulat, ada banyak ni duri-duri. So sea urchin is a radial. Kalau kebanyakan insect, arthropod, dia ialah bilateral. So in bilateral symmetry animals, they are leading to the evolution of cephalization. What is cephalization? Cephalization is the development of a head where sensory structures are concentrated. So, dah ada bahagian head dan juga body. Okay, bahagian head yang akan control. Bahagian head ni bahagian kepala lah. Macam kita, bahagian otak kita sebagai kita punya central system kita yang akan control most of the activity of the organism. So, bilateral symmetry and cephalization are considered as the adaptation for locomotion. So, cephalization penting untuk control all the activity including the locomotion, and bilateral symmetry yang control the body, macam bahagian badan, bahagian kaki kan, ada juga akan control the locomotion. So, both the bilateral symmetry ataupun the body symmetry and cephalization are very important for organisma punya locomotion. The head of animals meet the environment first and best equipped to capture food or respond to danger. So maksudnya nak cerita tentang fungsi of the head. Okay, head yang akan tafsir adakah itu ialah makanan ataupun adakah tempat itu selamat, and then bila the head made a decision, and then the body will follow. Okay, sistem dia sama macam manusia. Kita akan fikir adakah benda itu okey, and then kita akan mengarahkan body kita untuk ke arah tersebut ataupun menjauhi sesuatu perkara itu. Same process. Okay? So this is the image of the radial symmetry and bilateral symmetry. Okay, and then yang ni awak kena tahu. Okay, bahagian nama-nama ni, dorsal yang mana, ventral yang mana, anterior bahagian depan, posterior bahagian belakang. Okay, ataupun nama dia caudal ataupun cephalic. Benda-benda ni nak kena tahu. Kalau midline kita panggil medial, from the word medial. Medial tu maksudnya tengah-tengah. One side of the body kita panggil lateral. Okay. Towards the head of the body kita panggil superior. Towards the feet kita panggil inferior. So anterior dengan posterior ni pun sama maksud dia. Cuma anterior and posterior are used among animals. Kalau in human kita tak panggil anterior posterior, kita panggil superior and inferior. Itu saja. Okay, so bilateral symmetry animal has 3 axes. Okay, dia ada 3. Yang pertama sagittal plane, frontal plane, cross or transverse section that separate the body into anterior and posterior part. Okay, type of body cavity. Okay, during the early development, most animal group consists of 3 embryonic tissue layers called germ layers. Okay, ini adalah lapisan-lapisan sel sebelum dia specialize into specific cell. Okay, dia daripada bulat. Okay, and luar kita panggil ectoderm. Lapisan tengah kita panggil mesoderm. Dan dalam endoderm. So yang paling luar ni, okay, sel yang paling luar dia akan give rise, dia akan membentuk, okay, the outer covering of the body to the nervous system and to the nervous system. Bahagian dalam endoderm dia akan membentuk the lining of the digestive tube and other digestive organs. So dia akan membentuk inner organs. Mesoderm, okay, dia akan membentuk muscle, skeletal structure and circulatory system. So yang ni awak boleh memorize dia lah. Okay, awak kena ectoderm luar dia akan membentuk sel-sel saraf. Okay. Endoderm bahagian dalam mesti bahagian lining organ-organ dalam. Mesoderm ialah tengah-tengah. Okay. Okay, so this is the process. Okay, macam mana cell specialization tu berlaku. From the zygote dia akan melakukan mitosis and then form blastula, and then dia akan bentuk blastosome. Okay, and then dia akan melakukan gastrulation, iaitu pergerakan sel ni ke dalam. Okay, dia akan bentuk macam ni, and then proses gastrulation ni sangat penting sebab dia lah yang akan membentuk ectoderm, endoderm dan juga mesoderm. Okay, gastrulation lah yang membentuk cell specialization. Okay, so the parazoan develop into 2 germ layers. Okay, ectoderm and endoderm, and they are referred as diploblastic. Okay, the parazoa ni yang mana? Cuba check balik yang tadi. Okay, the cnidarians, okay, and ctenophores. Okay, although they are not members of parazoa, develop only 2 germ layers and are also called diploblastic. The eumetazoan animals develop 3 germ layers. Ectoderm, mesoderm and endoderm are called triploblastic.